Hello everyone. Today, I will provide basic information on how we will conduct the performance analysis of the masonry wall structure that we modeled in the previous video using the STA program. One of the most important factors in the performance calculation of masonry wall structures is material information. It is necessary to input the material values accurately. Here, I need to mention the following regarding the material information. As you know, when you do not perform a performance analysis and instead carry out a normal data solution, we used to write the FD value divided by the strength reduction factor here. So here, if FD is 20, our FK value actually becomes 40, provided that your masonry element is not made of gas concrete. However, our regulation requires that the FD value be entered the same as FK in the performance calculation. For this reason, I am entering my FK value as 40 here. Of course, when I enter this value as 40, our elasticity modulus value automatically changes. I am very carefully restoring this to its original state. We need to write down the value of FPK0 that we found either from the experiments or from the regulation table. Here, I am taking it as 7. When you select any mixed unit here, these values may change automatically. However, these are default values. You can also change them manually. Just like this, yes, in this way, our material has already been assigned. Our material is E2. We have entered its features. After entering this, we again come to the performance options here. The structural performance. Project option must always be checked. Since we have a masonry wall structure here, we select the masonry building performance option. Apart from that, all the data here is for concrete structures. So all the options are irrelevant to us. Only the building data level factor here is important for us. If you have a comprehensive information system, you enter a value here. If you do not have a comprehensive information system, there are also items to manage. You need to enter the value of 0.75 here. Yes, I entered 0.75 here. I assumed it was at a limited level of information. After that, we will input the R value here. Of course, our earthquake value has not been entered. We need to input that as well. This is important. In performance analyses, at the R value, you can use a value of 2.5 for masonry wall structures, if you wish. However, to stay on the safe side, I consider the performance analyses of normal structures as a value of 1 here as well, once you take this as 1. The other values don't really matter much anyway. Because our other values related to the earthquake are more significant, we have already considered the R value as 1. Your earthquake is very important. Make sure to include this. Because these earthquakes create shear effects on your masonry walls, the performance calculation in masonry wall structures takes shear effects into account and determines performance accordingly. Therefore, the effects of earthquakes must be input exactly as they are in normal performance structures. Yes, after entering here, of course I mentioned the design standards for masonry buildings in the previous video. These are important, and I stated that we need to pay attention to them. It is also beneficial to have these options available in the calculations, especially when referring to the new structure model. It is important, but controls are also significant. It is beneficial to mark these. They should be marked this way. Other than that, there is actually no other step we need to take, as our materials are, of course, selected here. Here, we entered the material value. Since there is an existing structure, it is important to accurately calculate the necessary core values for the vertical tie, which is the E3 material, and input them here. After doing this, our structure is ready for performance analysis. There are no additional processes required. Yes, I will. Conduct the performance analysis in this way. However, there is a very important point. The performance analysis of masonry wall structures is always conducted using linear finite element analysis, FEA. You cannot choose a simple linear analysis here. You need to select finite element analysis, FEA. Since there are no reinforcements present in the interior, a non-linear analysis can never be performed. Any type of linear analysis will be conducted for masonry wall structures. However, it must also be carried out using the FEA analysis method. Normally, you cannot choose the linear analysis option as you would in the performance calculation of a concrete masonry wall structure. If you wish, you can create a model of the foundation of the relevant masonry wall structure here to see the incoming stresses, and by entering the material values, you can also assign the option of reinforced concrete if you wish. Yes, we have assigned this as well. Now, we will save it and perform the performance analysis. Yes, our performance analysis has been completed here. Yes, as seen, limited damage is observed in the structure's performance. Our regulation already requires us to achieve controlled damage at a minimum. We have provided limited damage, which is even better than that. There is no issue at hand. How can we view the detailed calculations? We click on the Performance Report button for the structure prepared according to the 2018 regulation. When we click it, it explains the calculations that have been made here. Initially, the formula for calculating. The rigidity value of the relevant dollar is provided. This is important. There is another important factor here. I will explain this from the regulation. The design strengths of the walls under vertical loads are present. Here, the NRD value must be less than the design force acting in the vertical direction, which is smaller than the capacity value. When calculating the capacity value, you already know the FD value. I explained it in the previous video. It multiplies this value by the area. The wall area reduces the number of certain slenderness reduction factors, while also maintaining safety. The number of capacity reduction layers related to the masonry wall. This number of capacity reduction layers is calculated based on the ratio of the effective height of the wall to the effective thickness of the wall, as specified here. If this value is less than 6, we say it is not fragile, and we do not make any reductions. If it is between 6 and 10, we take the value of 0.8 and reduce it. For values between 10 and 15, 0.7 is taken. If it is greater than 15, this is not allowed. In other words, such modeling cannot be done. It is never allowed to exceed 15. What is actually shown here is the mathematical expression of that statement in the regulation. What is important here is that there is a formulation present. How is the effective height determined? Now the wall has a free height. The expression here is the HK value. This is multiplied by the coefficient here. So, how is this coefficient calculated? If our wall is a wall in the middle like the one here, and there are other connecting walls, then 0.75 is taken. However, if it is on the edge, with only one connection from here, and one connection from below, like in this case, then 1 is taken. And this is how the effective height is calculated. Since it is the effective height, it is not always the same as the free height of the wall. The free height of the wall is already here. In other words, the free height of the wall is the distance from the upper floor level. For example, from the floor level here to the lower level of the beam if there is a beam. And when calculating with respect to the regulations, the expression of free height is also used here. This is shown here. These are important from a logical perspective. Besides that, yes, now we come to the calculations. The operation performed in the calculations is as follows. First, the sliding rigidity centers of the floors are calculated. Here is its calculation. The values of XR and YR are found here. After these values are found, earthquake loads are distributed to the walls based on the rigidity centers. And this shear effect is created on the wall. Here you can see a formulation that shows the distribution of earthquake loads to the walls based on the rigidity centers, and rigidity centers are used here. The values obtained here are the shear values. These are distributed to all the walls. Of course, it is distributed in this way based on the rigidity centers, and it also creates shear forces in the wall. In summary, rigidity centers are identified. Rigidity centers are important for determining the shear forces acting on the floors, specifically in relation to earthquake loads. The earthquake loads are distributed to the walls as shear forces. The shear force is generated in wall 101. Of course, since this wall is in the X direction, a shear force is generated in the X direction. On the other hand, the wall in the Y direction generates a shear force in the Y direction. Calculations are carried out in this way. The formulations are also here. The logic is as follows. Here, the distribution of earthquake loads is already shown. How are the total shear forces found here? That is also included. The formulation is already here. It is also presented in a tabular format. Then it is distributed to the floors like this. After these are distributed, the shear stress resistance in the walls is also checked. Shear stress resistance is very important. What we actually refer to as shear stress resistance. We had the FBK0 value that we entered here. This is important. The FBK0 value refers to the characteristic initial shear strength. This also affects the entries into the lower range. I had explained the contribution of the lower range entries by using the formulation here in the previous video. The FBK value, which is the characteristic shear strength, is determined, and it is checked whether this characteristic shear strength is greater than the shear strength applied to the structure. Look here, it has come to 5.488. There is already a very large difference from 0.464. That's why all of them are checked. If it were not sufficient, we would have needed to increase the concrete thickness. We would need to proceed with strengthening, and the minimum BC value would be written here. There would not be any trade here. The minimum BC value indicates the necessary minimum concrete thickness in cases of inadequacy. It will show us where reinforcement is needed. This FBK0 value is already the value we entered at the beginning, if I need to show it again from here. Yes, we entered a value of 7 here. However, it is considered as 5.25 here. This is because, as seen here, the reduction in delicacy is represented in this way, by the reduction factor. If our ratios had been less than 6, then the ratio of effective height to effective thickness would have already been 1. The fragility reduction coefficient and our FBK0 value were to be considered as 7. Generally, this condition is already more than sufficient. Following that, there is the shear capacity control here. Here, we check whether the value of the shear force that occurs in the relevant wall, indicated here as VR, is smaller or larger. It provides information about the relevant wall and states that if there is a deficiency here, we need to increase the concrete thickness, also giving a specific thickness value. Of course, this thickness value must be at least 5 centimeters. At most, it can be 10 centimeters. Anything beyond that is not applicable. It's between 5 and 10 centimeters. Of course, you can increase it from both sides, then you can strengthen that relevant wall from both sides, like 10-20 centimeters, from both the left side and the right side. This is a situation that is up to you. In that case, you can reinforce up to 20 centimeters. Otherwise, it does not become a very healthy situation in terms of usability if it is more than that, or a reinforcement of less than 5 centimeters. Since there is no problem here, everything is checked and marked. And here, our value is smaller than the VR value for all walls. After this, we proceed to the last. Yes, here, there was shear control of masonry walls. Here, there is story shear control. This control is being performed in both directions. The total shear force generated in the X direction, and the total shear force generated in the Y direction. We have actually already found these values here, on a story basis. Of course, we only have one story. If there were different stories, we would add them here and check them. We had calculated these values here. Then we write the total values. This is also the overall total capacity value. The total capacity of the walls in the X direction is 612.78 on a story basis, and in the Y direction it is 595.83. As can be seen, the capacities are very strong in response to the very high forces. There is another shear value. This shows us the following. Now we have the total and our value here, as seen. These values are of course within the masonry walls. Look, we just did a check like this. The value for wall 101 is 6.95, which is less than 82.82. Now, I am giving an example on a wall basis. The value for wall 102 is smaller than this, and the given value is small. However, for wall 101, it may be larger. It says that the larger values here, let's say that this is not VE, were greater than 82.32, it was 85. Let's say it was 17 here, and it was greater than this value. It says to take 85 and 17 and add them together, whichever is greater. You sum the larger ones. Here, since none of them are large, it is 0. If there were large ones, they would have been summed up, and the ratio of this value to that value is also being considered, meaning the ratio to the capacity is being looked at. If this ratio is above 40%, your structure enters the collapse zone. If it is below 40%, controlled damage occurs, which is what the regulations already require. If it is completely 0, meaning there is no value greater than 0 in any masonry wall, then, as seen, it becomes 0 and results in a limited damage condition. We need to ensure controlled damage as per the regulations. If this ratio exceeds 40% and the total V value is already less than 40%, it could have been different in the end. This example is in that manner. In such cases, we would then proceed with tripling. As we mentioned here, we will increase the thickness of this concrete in the tripling. We will increase the relevant masonry wall by a minimum of 5 centimeters and a maximum of 10 centimeters, either from the left or the right side, according to the project. This method is referred to in the literature as shotcrete. If we already had inadequacies, a button would have appeared here, and this button for strengthening the masonry walls with concrete is removed, and when you click on this button, it automatically updates the calculations by adding shotcrete to the relevant walls and presents the results to you. If there is still inadequacy afterwards, the same button will appear again, and the concrete thicknesses will be increased to apply shotcrete once more. This is how it is. However, you can of course add manually as well. I will show you how to make manual additions here. Here, we already have sufficient strength, but when reinforcement is needed, how is it done and how should it be done? To demonstrate this, I will now make an example, addition of a shot quality. and we will observe how much these values have changed. We will have observed that the capacity values have changed significantly. Yes, we have now returned to our model file. Here we will be adding shotcrete to some of our panel elements. First, I come to the story arrangement section here. I select the masonry wall option, and I choose the panel elements that I want to add here. I am entering the general modification button. The general data modification button, as you can see here, we have two options for adding concrete, one for negative and one for positive. We can determine how many centimeters. We will add from both, the left and the right sides. Here, I will add the elements here from one direction. I will add 5 centimeters from the right side. As you can see here, there is mesh reinforcement inside the shotcrete. Mesh reinforcement is being added constructively. These mesh reinforcements are added at a density of 1 per 1,000 sections. This is important. Here, of course, we are also calculating rigidity. Now, the rigidity calculation will change somewhat for the addition of concrete. We consider the rigidity of the concrete to be 5 times greater than that of the masonry wall, ensuring that we remain on the safe side. Concrete is much more rigid than the masonry wall, but we'll assume it is 5 times greater and perform our calculations accordingly. So here we are considering that the strength of the shotcretes will be 5 times greater than that of normal walls, meaning masonry walls. Yes, it has currently been set at 5 centimeters. When I say it has been cut, it means that the shotcretes have been added. Of course, we added it on one side here. You can see that it has been added in one direction. Now, I am also selecting the view center wall option again. As seen here, I will add to both panels from 2 directions. I will add 5 centimeters from both sides, as shown with the markers here. Yes, as can be seen from here, additions have been made from 2 directions. After these are completed, I am recording a different identifier here. I will review the performance again now. Yes, our analysis is complete right now. We are returning to the performance report. Yes, look, my capacity ratio in the first section is 612. The value increased to 682, and the capacity ratio in the Y direction rose to 660 from 595. And the capacities have increased somewhat because we made additional conditions in both the Y and X directions. Since the number of capacities has increased, this ratio will decrease here. Currently, of course, 0 has no significance. It is 0 at the moment. But when there is a ratio, this ratio will decrease. Because the capacity value is increasing, it will gradually drop below 40%. This way, we will have brought the control mesh reinforcement to the structure if the structure is in a state of collapse. Here, of course, a certain amount of related total cuts have also increased in the structure. However, since the increase in capacity is much greater, our structure has been strengthened here. Look, we made an increase in the P102 panel. Its capacity increased from 1660 to 2213. The capacity has increased here as well, as on the wall basis. We also did it in P118. In P118, it increased from 65 to 88. In P111, it is 111. It increased from 65 to 82. It has increased to the value of 66, and we are also looking at P113. Yes, it has increased significantly. It has already risen to a value of 139. The reason for the much greater increase in P113 and 111 is due to being wrapped in both directions. In the others, there is a somewhat smaller increase. Because it is one-sided, we reinforced 118 and 102 from one direction. Reinforcement from both directions is also beneficial in this regard. If you have all the possibilities, it becomes a much more comprehensive approach. Yes, this is the effect of the analysis result. And of course, we can incorporate these into our drawings. Here, when we come to the column application plan, yes, we are adjusting the scale factor here. After adjusting, you can see the mesh reinforcements that were placed here when we drew the formwork application. So you see the grid bars, they are being written about, specified. It also shows how many centimeters of short grid have been applied here. Information is provided about the type of mesh reinforcements used here. You can view these from this point in the column application plan. Yes, the information about the meshes used here is also written. At the same time, we had used vertical tie here. You can see its drawing and the reinforcement used here. Here, a vertical tie. Yes, definitely. This was the way. And of course, this was the application plan. You can also view the panel section, details in this way. The panel option needs to be checked here, because the wall structures of MESA are modeled with panel elements. If this option is checked, you will also be able to obtain the cross-section details of your panel walls. Here, right now when I click, yes, look, here, the wall details are being provided. The relevant mesh reinforcements are also provided in the walls added to shot grid. As can be seen, these are specified within the wall detail. And of course, I have created a model for the vertical tie as well. Its reinforcement is also provided in this way, as a drawing. Besides that, I am now closing this drawing. I am coming to the form application detail. In the form application detail, I first adjust the measurement. After adjusting, when I take the drawing, it gives me the reinforcements for the normal slabs. However, it also indicates the added SHAT credits. Here. When it comes to the education section of our program, we have a comprehensive PDF document that is directly related to the topic at hand. This document contains a wealth of information and is designed to provide you with a deeper understanding of the subject matter. I highly recommend taking the time to thoroughly review this PDF, as it offers more detailed and extensive information that will be beneficial for your learning and comprehension. Yes, look here, our PDF document titled Retrofitting of Masonry Buildings is very important. If you examine this PDF file, it will also be beneficial for you. Yes, this is all I have to say on this matter. Thank you very much for having me. I wish everyone good work.